In this video, we are going to talk about data cleaning. If you are working on the real world project, the data you might get will have this type of problems. And the first problem that we might face is data type mismatch. In this video, we are going to talk about this problem and how to solve this problem by cleaning the data. So this notebook explains how to identify the data in the columns with the wrong data type, and we are going to take the help of pandas module. So we are going to discuss about pandas module and datetime module. So in order to work with the pandas module, we import it first using this command, import pandas hbd. Then we import a datetime module because we will be working with date and time. And just we have also imported numpy just in case if we need some mathematical computation. Now let us create the data by ourselves. So here we have created a data frame with the help of pandas module, and here it contains 4 columns A, B, C, D. So these are the column names, and each of these columns has these entries into it. So whenever I run this line of a code, then you can see the column A contains the word text created 20 times. So see here, the word text has been created from index 0 to index 19. So that means it is created 20 times. So using this line of code, we have created the text 20 times. I can also show you right here. So if I do something like this, text into 20, then I'll get text that is 20 times. So this is a string. So the column A or a variable A contains a string. So these text are string values. Similarly, we have second columns that contains numerical values. You can see they are floating number. So all of these numbers are assigned to column B. Now speaking of column C, they are either true or false. So that means they are the collection of Boolean values, and we created them, that is 20. So first will be true and false, again true, false. We have up till 20 of them. So first we'll create true, and then we create false, that is 10 times. So altogether there will be 20. And at last we have D columns that contains all the date time. So this is the date time, and we use the pandas to create this date time with the same value that has assigned to each of them. Now you can see the A contains here the textual data, B contains the numerical data, C contains all of them as a Boolean data, and D contains all of its attribute as date time data. I can also check the type of them. So data frame is the data that I have created. So I use the df since it was the df that I have created right here. So its name was df. So I use the df, and then I'll give dot, and I want to call a function that will be info. If I run this now, then you can see the A has the data type of object. So basically it is a string or a text. The column B is floating value. The column C contains 20 values that are Boolean, and column D are date time. So in this way we can see all of these are having their own observation of the same data type. So within A, we can see all of them are text. Within B, all of them are numbers. And the C column contains all of its entries as boolean, and D contains all of its value as date. But this ideal case might not be in real world data. Instead, we can get data something like this. So I will tamper with our data, the original data. I will change this data. For example, here in the column A, I will insert some of the numerical values also, like numbers. I will insert some numbers in column A, and in column B, I will insert some textual data, maybe text, and into column C I can insert some, that is date time also, and in the D I can insert some numbers, some boolean, and so on. So I will tamper with our original data. So here is the data that I have just added. So see here, with this line of code we are going to add a number 1 to the first column and first row. So that means the value 1 will be added right here now after we run this line of code. Now see here, if I run this line of code, then I got the final data frame, which is messy now. So you can see the column A is no longer the same data type. It contains date, it contains some numbers and the text. Similarly, the B contains numbers, and you can see this 2.2 here. The value 2.2 I have added is as a string. See here, this was added as a string. So this 2.2 is in fact a string because it is inside this quotation mark. So I have inserted it in the 5th row and first column. So that means I will be adding it in the B in the 5th observation. So this 2.2 was in fact a string. So this is a string that I have added right here. Although this looks like in this case as an integer, but whenever we print the data frame, this quotation is removed. So that was the reason we didn't see this 2.2. In fact, what I can do is, instead of making this confusing, I can just type here hello and I'll put it as a hello. So see here, now you can clearly see this is a text. So that means now within a column we don't have a similar data type, rather we have a heterogeneous data type. So within D here, so this is the column D, and D contains the date also, it contains numbers also now. So that means we have heterogeneous data type. Now we need to clean this in order to make our machine learning model more accurate, because if you make the use of this data, then this data is not cleaned, because in each of the column you must have a same data type. So that means if A is, like let's say, is a integer, then in fact all of its observations should be integer. Now we have messed up with our data. Let us check what is the type or the data type of our new data frame. So I'll go down here and I'll just type type and pass data frame, or you can also do something like data frame dot info, and if I call this, then you can see now all of them are object. So it was not able to just recall what was the type of this data, although you can see the majority of data was our numerical value like float value, but it was unable to check, so it only give us an object. So that means we need to remove this. We need to make sure that in a particular column we have a similar data type object only. We don't want string, numbers and boolean within the same column. So for that we can just identify the mistyped data first. So the function apply map and is instance can be used to identify mistyped data type. So here I am going to identify in our data frame which of the values are integer and floats and which are not. So this is the code that will return us a true if the data is either integer or float. Basically, if the data was number, then it will return us a true. If it is not, then it will return us a false. So apply map here takes each of these data, give it to the lambda function, and that data will be checked inside this function. So this function will check if the value x that we will send is either integer or float. If the value that we sent is either integer or float, then it will return us a true. If it is not, then it will return us a false. So for example, if we go to our data, then see here in our column A, the first number, the first that is observation is 1. So this 1 is in fact integer. Now this code will check if it is integer or float, and yes, it is integer. So that means our number was integer, so that is the reason we got true. And similarly, if I check for another data, let's say I want to check for this one. So it was 6 observation and I'm checking for the column A and it was text. Now text here is not a number, it is a string. So now we should get false for this. We will only get the true if it is number. Here it is not a number, so I think we will get false. So let us check for 6th observation and column A. So let us go down, 6th observation and column is A, so we got false. So this will check or identify if the data that we sent is either integer or a float. So we got this combination of true and false. If the data was the integer or a float, then we will get a true. If it is not, then we will get a false. Just by looking here, I can predict the 9th observation, and this D column here is not an integer because it is a false value. So this value should not be integer or a float. This should be something like boolean or dead time. So in fact it is a dead time. If you go over here and check it, 9 and the last one is this one, so it is a dead. So in this way we can identify if the particular observation is a number or not. And instead of here that is integer or float, if you put something like str, then this function will check if the particular observation is string or not. And similarly, if you want to check if the particular observation is any other object, let's say boolean, then you can do it like this way. So you can change any instance of your observation by this apply map. So apply map will take all of these one by one, give it to lambda function, and lambda function will check here if it is integer or float. And you must remember this function is instance. This is a Python function that will check if it was the instance or the object of this class or not. So after checking this, here I can also only get the particular column value. See here, initially we got the value for all the columns. We got for A, we got for B, C and D. But what if I want only the value of B column? I don't want to see A, C and D any longer. I want only the value of B column. Then what we can do, for the same code that we have written previously, I can just slice the B column. Now see here, so this is only the B column. If you initially check our B column before we messed out it, so our original data, so the B column was in fact initially it was a number, it was numerical value. it was a float value or a number value. So B column was initially floating value. We added something to it like this. In the B, we added hello and we added A plus B. So now it was messier than before. Now it contains the heterogeneous data type. It is no longer only the number. It is in fact an object now. Now we need to find what is the thing that doesn't match with this column B. So if I go over here, then the column B was in fact an integer. Most of its value was a number. So you can see the first one was number. So that is the reason we got true. And the fifth observation and the seventh observation was not a number. If you go up and check, then fifth and seventh. So fifth and seventh. So these two are not numbers, and that is what we got right here. Now using the information, we can filter out the non-numeric data. So for example, see here, so this was my numeric data. Now if I want a non-numeric data, then I can just give this tilde over here, specifying the not operator. So basically this tilde, this sign, determines not. So doing this, you are saying give me not numeric. So not numeric means not the number. So give me the rows that are not numbers. And if you remember, these were the two rows that was not number. So I can just revert it back, and if I run it, then you will see that I got an error because we haven't executed this. So first of all, execute this one, and now if I go back and execute this, then you can see these were the two things that was not numeric for the column B. So column B was initially all numeric. We added these two things intentionally to the column B to make things like mixed data type. So the row 5 and 7 was the two values that was not numeric. So in this way, we filter out non-numeric data. If you want numeric data, then what you can do is, see here, you have a non-numeric data by using this tilde. If I remove this tilde and execute it, then you can see now I got the data that is all numeric. Now execute the B, see here. So in the B case, now I have all the data that is numeric. We have just removed these two false values that was not numeric. So in this way, we can filter out our data. Similarly, let us say that in our column D initially, see here, all of it was dead time. So all of its value for column D, just check this out, all of it is dead. So these are dead. Now after we added something to our D column, I added a number to it. You can see it is no longer dead. And similarly, I have also added this string by this code. Maybe I can just type anything like hello again and execute it. Then you can see in the D column, I added a number 12 and I added a hello. So now this is no longer a column that have a same data type. Now D contains date also, it contains integer also, it contains string also. So our task is to make the same data type by removing this value 12 and hello, because they are the minorities. They are present in a small number. What is the maximum that is values in the D? That is date. See here, this date has the maximum number. So that means we want to remove this and we want to make this column as date time data type. So for that, what we can do is we can refine again. So see here, so I'm checking for the D column now, and apply map is basically going to apply all of these observation to the x, and I'm going to check now if the x here means observation, each and every observation will be taken by this function, and it will check if it is date time or not. If it is, then return true. If it is not, then return false. If I run this, then you can see the observation, that is second observation, and the 12th observation is not date time because we have false at this observation. Other than these two observation, we have all the values of true. So that means except 2 and 12, others are date time. So let us check for two observations here, the 2 observation and 12th observation, and both of them are not our date time. See here, the 12th observation is a string and second observation is a number. Other than that, all are date time. So we need to filter out those things from the date time. So for that, what we can do is we go here and we find a filter which will give a true if it is a date time and give us false if it is not. And using this filter, now I can refine our data. If you do something like this, then this means from our data frame, just negate this filter. So this filter will give me, that is date time module, true if it is date time, false if it is not. Now this will give me those cases where the value of D is not date time. See here, so this negation will give me that. If I remove this negation from here, the tilde sign, then I will get all the date time. Now if I run this, then you will see all the date time in the column D. So we have just removed the value 2 and hello from the column D using this line of code. So first make a filter using this code and then just assign to our data frame, and this way you can refine our mismatched data type. Now finally I will check for the column A. So initially if I go up, then our A, which was the column A, contains the text. See here, all of them were text. Each and every were text. And then we mismatched this data type by adding some jargon to it. Like I added numbers to A and some numbers also added here. And similarly I have added a date also to column A. Now the column A is no longer having the same data type. Rather, it is mismatched data type. It contains multiple data type. It contains number also. It contains this text, which is a string values, and it also contains date. Now in the real world scenario, this might happen. So in this case, what you need to do is you need to clean your data and make a homogeneous data type. That means you need to remove this mismatched data type. Like from A, you need to remove these two numbers and you need to remove this date also, because majority of things in the column A is a text. So we go to the majority things and make it as a majority. So for that we need to remove now these numbers and the date from column A. So let us do that right here. So for that we are going to again call the apply map, and here we are going to check if that value is a string. And here if I don't have this A here right now, if I remove that A, then you are going to get everything for all the columns. But now I don't want to look at the column B, C and D. So that is the reason I will pass here the slicing technique. Just give me A part. Now if I run this, then you can see I just got the A part. Now in the A column, the first instance, second instance, and the 10th instance are not string. Other than that, all of them are string because we got all the true value except 0th, 1, and 10 index. So let us confirm it. What was in the 0th, and that is 10, and that is 0, 1, and 10. So if we go to 0, yes, it was mismatched. 1 was also mismatched, and 10 was also mismatched because both, and this one is not a string. Now using this filter, again we can refine our data. So see here, just use the same filter. I have called my filter name as a string. So pass the string to our data frame now. If you do data frame strings, then you are going to get all the strings from a column. See here, we no longer have now those numbers and date. Now if you want those numbers and date, only those numbers and date, then what you can do is you can just put here tilde. So after putting this tilde, to it, now you are going to get not of strings now. So this basically means give me not strings from A, because this filter, strings filter, is applied on A. So this code will tell us give everything for me which are not string from A. If you check in the A, what are the not strings? So this is not string, this is also not string, and this is also not string. Other all are string. So we are going to get 3 rows containing numbers and the date. See here, number, and date. So we are not going to get only one column, rather we are going to get all the observation. See here, the entire row. Now we can directly remove this and filter our data frame. For example, you can see here, after we remove it, we can store it directly to our data frame. So here I can do something like this. So I filter out the D, and that was our filter, and here dt is my filter. Now dt will tell us that dt contains the datetime module or all the observation that is related to datetime. See here, all the observation that is datetime only. It is not mismatched anymore. Now after you find and remove the mismatched, you can directly replace to our original data frame. So in this way, now our data frame will be cleaned. So this is the way to handle the data type mismatch, and this is a common problem that we get if you are working with a real world project. So instead of the ideal case where the columns will have all the observation of the same data type, we can have the mismatched data type. Within a column, we might have different data types. Data types here means either number, string, or float values.